Okay, here we are talking about standard deviation. Um, and I'm on slide 18 in the descriptive statistics presentation. So, standard deviation technically is the middle 68% of the data surrounding the mean. Um, it's basically the typical distance away from the mean a data point at random is expected to fall. So standard deviation. Deviation refers to some kind of departure from a middle point, and standard just is a standardization of that. So a typical distance away from the mean, a data point is going to fall. If you pull a random data point out of a set and look at it from the mean. So it's the spread of the data around the mean. If your standard deviation value is zero, that means there's no spread. There's no difference whatsoever in any of the score values. All scores are the same value. If you have small standard deviation, that means your data are compact. They're tight around a center point. If you have a large standard deviation, that means there's more spread in the data. There's more variation in the values the scores take on in your data set. That's typically seen in treatment groups. Usually, treatment groups will have a little bit higher standard deviation value on the dependent variable than control groups, and it's because of the differential impact that treatment's having on people who are receiving it. So the advantage of the standard deviation is that it's very robust. It's used alongside the mean. So the mean and standard deviation are used alongside one another and reported alongside one another. So the standard deviation is all inclusive and uses every score as the mean does. That also makes it the most stable measure of variability. But like the mean, it's also affected by extreme values or outliers. So that can produce higher variability as well, as reflected in your standard deviation. So slide 19, the example, a few years ago, more than 10 years ago now, when the Suns were at their peak, they were doing really well. They had Steve Nash and all those other guys, Amari Stoudemire and Sean Marion. The Cavs had LeBron James, and the Lakers had Kobe Bryant, and people like that. I remember I had some sour grapes because the Suns were always fighting against the Lakers in the Pacific Division, and I thought, I think the Suns are the more balanced scoring team as opposed to the Lakers, kind of living, live and perish by what their star Kobe Bryant's doing, and definitely Cleveland. I thought was pretty much LeBron James's contributions and like nobody else. So I thought, I'm going to go ahead and see statistically if that's borne out. So if there's an outlier in the data set, that should pop up with a larger standard deviation value in the data set. So what I did was I took the average number of points per player per game in the season 2009, 2010 for the Suns, Lakers, and Cavaliers, and lo and behold, I actually found evidence to support that there's greater variation because of outlier data points, and outlier data points here indicate a player or two on the roster that score a lot of points and everybody else scores very few relative to that. And so I actually saw that on in the data here as indicated by the standard deviation. The Suns had more points per game on average per player, and the standard deviation was lower than either for the Lakers and for the Cavaliers, which was interesting because my whole contention was the Cavs are pretty much just being um, uh, helped along by LeBron James and his awesome point tally every night, and that's it. If you take him away, the Cavs are no good. And that actually wound up happening when he left Cleveland for Miami a season or two later. Cavs took a dump. And the Lakers, same thing. So I was like, wow, that's pretty cool. So outliers pull the variation broader in our data sets, and you can see that in standard deviations. Pretty cool stuff. So just to go over normal distributions on slide 20, a normal distribution is symmetrical. The mean, median, and mode, theoretically, all are located at the center peak of the curve. We need to know normal distribution because of the shape often found in nature, and it's the basis for what we do from statistical